how to use ice tables. So I've had a few people ask me this over the last few days, so I'm just going to make a quick video to direct people to if they need help with it. So here we have a question, which, well, I've seen a few times in the last couple of days, let me tell you. And a couple of things to note here. This is a typical ice question, and you can tell by the fact that it's asking about the position of equilibrium after altering the conditions of a reaction. We're going to kind of ignore this, but typically whenever you're asked to use the ice equation, they're either asking about the concentration of something after a... they're usually asking about the concentration of something after something has reached equilibrium, given the initial concentrations, or it's asking you about the equilibrium constant, which I suppose is kind of the same thing combined together, because the ice table pretty much gives you the concentration of everything afterwards. So what ice stands for is initial, constant, and equilibrium, with the initial concentration of all the materials involved, the constant by which they change, and the equilibrium concentration of everything involved. So given this question's information, you can see there's 2 moles of methane, so I've written down initial concentration 2. There's initially 1 mole of steam, so 1 H2O. And those 2 are allowed to reach equilibrium. It doesn't say anything about the others, so I'm just going to assume that they are 0, carbon dioxide and H2O. So now we just look and we can construct the constant. So both of these, 1 mole reacts. It's not showing the equation, but 1 mole of methane reacts with 1 mole of steam. So they lose 1x. And the way you can tell they lose it is because it tells you that the concentration is lower, but also, since there's nothing here, they have to lose concentration. One side has to lose concentration while the other side gains concentration. That's just how it works. It's conservation of mass. So because CO also has 1 mole produced per mole of reactant, we also have plus X on this side. But for hydrogen, it's a little bit different. It's a little weird because there's 3 moles of hydrogen. Instead of having 1x change, we have 3 plus 3x change. Now, you don't have to be very good at maths to tell me that 1 minus x equals 0.66. Quickly solving for x, that's pretty simple. 0.34 equals x. And so using that, I'm sure you can quickly go through now and solve for the remaining values that we need. So methane, 1.66. H2 is 3 times 0.34, which, quickly having shoved that into my calculator, 1.02. And as for CO, that's just a very simple 0.34, because there's only 1 mole change. Only 1x change, rather. So that's how you use ice tables to find the equilibrium concentration values given a change and the initial concentrations of at least one side of the reaction. So once you've gotten that, moving on, you can put those values into, and I might have forgotten some of them, so I have to go back in a sec, but to solve for Kc, you construct the equation, which is H cubed times CO. This is just constructing the equation for HC or Kc over CH 4, and H2O. And now that we have these two things done, we can just put in it's KC. Now, if we just quickly put in our values, so that's 1. Use this technology. 1.02 cubed times 0.34 divided by, what was it again? One of them was 0.66, I think that's the steam, and the other was 1.66, and that equals Kc, which if we quickly shove into our calculators, that is 1.02 times 0.34 divided by 0.66 times 1.66 should equal you 3.29, but since in the question it's given us two decimal places, we're just going to put two decimal places, so that's 0.33. As for units, each of these concentrations is in mole DM3, so 2 mole DM3s divided by 1 mole DM3, 3 mole DM3s divided by 2 mole DM3s, pretty much just taking them away, so that is all squared DM minus 6. And I already checked, that is 3 marks. Big tick. Kenny approval. I approve. This will get you the marks. So to quickly summarize, if you get given the initial concentration of something, and you're given at least one of the equilibrium concentrations, you can put this into an ice table using a constant to find the change for all the materials, because X is going to be the same. You just got to remember that this number of moles will influence how many X's it changes by. This video was a bit scuffed. I did this kind of quickly, but I hope people find this helpful, and yeah, good luck on your exam.